Okay, in this video we're going to take an introduction to derivatives. Very, very cool idea. So let's go ahead and start. So students will be able to know what a derivative is and how many ways you can solve it. So this is a huge, huge idea. Just like with limits, I want to go through a little intro. So if anyone asked you what a derivative was, the common sense definition is basically this. It's the slope of a tangent line to a curve at a point. So a slope of a tangent line to a curve at a point. Let me show you what I mean by that. I'll just sketch a little graph for you real quick. It's not going to be gorgeous, but what can you do here? So let's say that I have a curve, and let's say I have a value a on the x-axis, some number a. If I look straight up, this actually has a height. We can say that it's f of a, but more importantly, it has a slope at this location. And the tangent line to the curve, and I know it doesn't look like it's tangent, okay, at this point is the first derivative. So the slope of a tangent line to a curve at a point would be the first derivative. Very, very cool, because you know of basically slopes as something that you learned in Algebra 1 and a little bit of Algebra 2, and you would need 2 points basically. And there's other variations. You need x sub 1, y sub 1, x sub 2, y sub 2, and then you would basically find the actual slope with the slope formula. Well, in calculus, we call this the average rate of change. Okay, oh, I almost made a mistake there. Let me go ahead and put x sub 1 there for you. But we can actually find the derivative, the slope of a tangent line to a curve at a point, with only one order pair in calculus. It's really neat. But let me not get sidetracked. Okay, so how many ways can you solve it? There are 3 ways to solve it. So let me grab my highlighter. So 3 ways to solve limits, okay, and there's also 3 ways to solve derivatives. That's why I left limits on there for you, just to refresh, but also there's 3 ways to solve a derivative. So for derivatives and limits, same idea. So there's first the numerical approach. That basically means you use a table to figure out the slope of a tangent line to a curve at some point. Then there's the graphical method, just like before. That's using a graph, either given to you or drawn. And then the final one everyone seems to like is the analytic approach of solving the derivative. And that's using algebra or calculus. Neat idea. Took a lot of years for people to be able to develop this idea. Okay, so here's some examples. So numerical, using a table. Graphical, looking at the graph and finding the slope. And then analytic, actually using algebra 1 or calculus to figure it out. Alright, so some more basically terms. I think a big part of calculus that's difficult is there's so much language. It's its own language basically. So to be able to know that you need to take the derivative, here are some keywords. So several expressions can be used in calculus problems to mean find the derivative. The first one is called differentiate. Sounds kind of fancy. So differentiate. That means take the derivative. Find the rate of change. That means take the derivative. Find the instantaneous rate of change. That means find the derivative. Find the slope of the line to a curve. That means take the first derivative. And velocity actually is the application of the first derivative. Alright, we're doing great here. Okay, so now some more notation. I know this is a lot. You're going to see in other videos how easy it is once we get the notation down. If I want to take the derivative of, let's say, y, and there's 2 ways I can write that. I could either write it as y prime or dy over dx. So if I'm taking the derivative of y, I can write it 2 different ways. If I'm taking the derivative of, let's say, f of x, the way you would write that is f prime of x. And then the fourth one, which the ones that we use normally, basically looks like this. Let me grab Mr. Blue. This is for taking the derivatives of expressions. So if you had, let's say, 3x and you want to tell the reader I'm taking the derivative, you'd basically write this right here. D over dx. of 3x. So the derivative with respect to x of 3x. That way then you can do your business and actually take the derivative. Now this notation also could be d over dt. It just depends. You just have to make those two match. So if I had 3t to tell the reader that I was going to be taking the first derivative, I would write d over dt. And then I would do my business and take the derivative. Now the fifth one, I'm going to cross it out. I see it in some of the older textbooks, but we're not going to use this notation. Okay. I know this is a lot for one video, but it's all great stuff. So the derivative of f at x is given by, okay, this is called the definition of a derivative function. So this is actually how you find the first derivative. It says basically this: f prime of x is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. I know it's kind of scary. You saw this in pre-calc just with this right here, and it was the difference quotient, I believe. Here we're adding the limit, so you actually get a slope of a tangent line to a curve. And in another video I'll actually prove how to get that for you. Okay, so that, my friends, is just a little intro. I want to go to example 1. In example 1, I've got a parabola, and I don't have enough time to show you the proof of it, but just know we're going to actually prove that we have a tangent line at x that kind of looks like this. And with this much information, using another line called a secant line, so the secant line is at x plus delta x and x. So secant line touches in two spots. So the secant line will look a little something like that. Ooh, that's not a very good line. Anyways, we'll learn that through this idea, we're going to be able to generate the definition of a derivative, which looks like that. So let me see if we hit our learning goal. Students will be able to know what the derivative is and how many ways we can solve it. I do believe you'll be able to do that. I would say give the video one more go, and then please look out for the next video where I show you how to find the definition of a derivative. I'll see you on the next video. Thanks.